Hi everyone, in this video we will explain the position versus time graph that we create during our physics lab. For this experiment, we use a motion sensor connected to the computer to record movement and to real time. This sensor measured position in meters while the time was recorded in seconds, and the software generates the graph automatically as we move. This is my graph. And at the beginning, the graph is horizontal, lying around like 1.5 meters. This means the object was not moving and stay at a constant position. And then the line slope upward, which shows the object was moving away from the sensor at a constant speed. And next, the line slopes downward sharply, meaning the object was moving back toward the sensor. And the lowest point of the graph represents the closest distance to the sensor. And after that, the line slopes upward again, showing movement away from the sensor. And there is another flat section where the position stays constant, meaning the object stops moving again. Near the end, the graph rises once more and then drops quickly, showing movement away from the sensor and then back toward it. Overall, straight diagonal lines show constant motion and horizontal lines show no motion.
3.
Hi, my name is Abigail, and today I'm going to be explaining my graph. The graph I chose studies the relationship between position and time to understand how motion is represented graphically. Using a motion sensor and the Capstone software, I analyzed the different types of motion, such as moving away, staying still, and returning, and how can they be represented. The goal was to reproduce and analyze this graph, showing changes in motion over an 8-second interval. The first segment shows a positive slope, indicating motion away from the sensor at a constant speed of about 1.5 meters seconds. The second segment shows a flat line, showing that the object remains still at 1.5 meters. The third segment shows the slope rising again, indicating a faster motion away at 1.5 meters seconds. The fourth segment shows the position constant at 3 meters, meaning that the object was still. The fifth segment shows the slope negative, showing that the object returned towards the sensor quickly at about minus 2.0 meters seconds. The slope of the graph represents velocity, so changes in the slope shows change in motion. A steeper slope means like a faster speed, and a flat line means no motion. Conclusion. My first conclusion is that the object moved away from the center at a steady rate, paused, move away faster, pause again, and then return quickly to the starting point. The second conclusion was that the slope of the graph indicates a speed and direction upward slope, meaning motion away. Flat lines mean rest, and downward slopes mean motion toward the center. My third conclusion was that this activity successfully shows how position time graphs can describe different types of motion and help visualize velocity changes.
Hello, my name is Omar, and in this video I will be describing my graph. This graph displays the relationship between position and time. In order to show how motion is represented using slope, for this lab we use a motion sensor that releases ultrasonic waves and measures how long they take to hit an object and return. The Capstone program that uses this information to determine the object's position and speed. The purpose of this activity was to create a graph that models motions and specific positions over 8 seconds time interval. The first line on my graph shows negative slope, meaning motion towards the center at 1.5 meters in 3.5 seconds. The second line shows a stoppage at the center at 1.5 meters for 1 second. The third line shows the slope went down again, meaning I moved towards the center 1.5 meters in 1.5 seconds. The fourth line shows a stoppage for 2 seconds, which means I stopped in front of the sensor. The slope of this graph shows basically changes in motion of the object. So in conclusion, the graph shows that the object is moving towards the sensor at a constant speed about 0 to 3.5 seconds. Since the position decreases linear for about 3.0 meters to 1.5 meters, from 3.5 to about 4.5 seconds, the object remains at rest because the position stays constant after that. From about 4.5 to 6 seconds, the object moves towards to the sensor again, but faster, as it indicates by the steeper slope. Finally, from 6 to 8 seconds, the object stays nearly at the same position, close to 0 meters, meaning it stopped moving.
Hello, my name is Moises Leon, and today I'm going to be explaining my graph. The graph that I was assigned shows position and time of a slope to understand how motion is shown graphically. The materials and softwares that we used was first, we used the motion sensor, which uses ultrasonic pulses to measure how long sound waves take to travel to an object and back. This information is processed by Capstone, which is the software that we use to calculate the object's position and velocity. The objective was to create a graph showing motion at a certain position based on the graph in 8 seconds. The first line in my graph shows a positive slope, meaning motion away from the sensor at 2.5 meters in 3 seconds. The second line shows a negative slope, meaning moving towards the sensor at 2.5 meters in 2.5 seconds. The third line in my graph shows that the slope went up again, meaning I moved away from the sensor 2.5 meters in 2 seconds. The fourth line shows another negative slope from 2.5 meters to about 2 meters in about 0.5 seconds, which means I moved towards the sensor. The slope of this graph shows basically changes in motion of the object. So in conclusion, this position time graph shows that the object moves with a constant velocity in straight line segments, indicating motion. The object first moves away from the sensor at a steady rate until it reaches a maximum position, then reverses direction and moves back towards the sensor at a constant speed. This pattern repeats, showing that the object motion is consistent and involves changes in direction but not changes in speed within each segment. The sharp corners on the graph indicate moments where the object changes direction. So to finalize, this lab shows how we can use a sensor to indicate changes in motion and velocity.
Thank you for watching the video. So overall, in conclusion, the graphs show how motion can be represented visually, and the slopes show movement, and the flat sections show when there is no motion. And the motion sensor helps us to clearly see the connection between real movement and the graph. So a big takeaway from this lab is that motion can be represented on a position versus time graph, and I learned that a flat line means not movement, and also that positive slope means moving away and a negative slope means moving toward the sensor, and that we learn how a motion sensor collects real-time data and turns physical movement into a graph.